Now let's talk about particular solution for a differential equation. We know that if we have y sub c as the general solution for the differential equation and y sub p as the particular solution of a differential equation, then y can be written as yc plus y sub p. This represents the general solution for the differential equation. So far, we discussed the general solution, how we come up with general solution for a differential equation of nth order and with constant coefficients. Now, let us in general discuss what is the format of a particular solution. If we have an nth order, non-homogeneous, linear differential equation like an, the nth derivative of y, plus a1 y prime plus a sub 0, y equals to g of x, so we're dealing with non-homogeneous differential equation, then based on the definition of g of x, we can form y sub p. If g of x is just a constant, any constant, then the particular solution is going to be written as a constant like a. If g of x is just a linear expression, then y sub p is going to be linear, ax plus b. Then based on the information that are given in the question, if it's an initial value problem or so on, we can find a and b. If g of x is quadratic, then particular solution is also quadratic, ax squared plus bx plus c. If g of x is cubic, so if we have a cubic form, then yp is also written as cubic format, ax cubed plus bx squared plus cx plus d. If g of x is, for example, sine or cosine of bx, or if it's written as cosine of bx, then the particular solution is in combination of sine and cosine. We get a sine of bx plus, we can write it as, for example, c cosine of bx. If g of x is in exponential form, for example, if you have e to power bx, then yp is a e to bx. If gx has multiplication of a linear expression, linear times exponential, then yp is a linear expression, ax plus c times e to bx. So of course, if it's in the form of a quadratic times e to bx, then yp is equal to a quadratic expression, for example, ax squared plus cx plus d e to power bx. If g of x is in the form of, well, an exponential times sine or cosine, if you have the following case, sine of, for example, ax e to bx, then yp, the particular solution has the form of c1 sine of ax e to bx plus c2 cosine of ax e to bx. If g of x is written in the form of, you have a quadratic times a combination of sine or cosine, so quadratic sine bx, then yp can be written as, well, we have a quadratic times cosine plus a quadratic times sine. Ax squared plus cx plus d sine of bx plus ex squared plus fx plus g cosine of bx. And finally, if you have the following form, if we have g of x written as, for example, a linear expression times an exponential, let's write down e to ax, and you have, for example, cosine of bx, then the particular solution can be written as, well, you have a linear expression like cx plus d times your exponential function times, well, cosine of bx plus another linear expression, ex plus f e to ax sine of bx. So these are the cases that we have if we have a non-homogeneous linear nth order differential equation. Based on the definition of G, we can come up with the general form of our particular solution, and based on the information given in the question, we can identify what A, B, C, and the rest of those numbers or coefficients are.